Everyone, in this video we're going to be looking at some word problems that use right triangle trigonometry. So there's a whole bunch of real world scenarios that can be modeled by right triangles, and we can use our knowledge of SOH CAH TOA to help us find missing sides and angles with and without given diagrams. Before we dive into that, there's two vocabulary terms that we need to know. So the first is an angle of elevation. That's the angle that's formed with the horizon, like it's often referred to as the ground in a real world example, going upward. And then the angle of depression, that's formed by the top of the triangle and the piece that's going horizontal from there. And I want to point out one key thing there, that angle, the angle of depression, is outside of the triangle. So if we look at this, the angle of elevation and the angle of depression, they're in different locations, but what's the main idea is that the angle of elevation is in the triangle, the angle of depression is outside of the triangle. But let's think, why are these two angles congruent to one another? And what we might notice, and particularly in the angle of depression example, is that these lines are parallel to one another. And when you have parallel lines, you have alternate interior angles that are formed and congruent. Alternate interior angles are formed when parallel lines are cut by a transversal, which is basically what the hypotenuse of the triangle is acting as. So these two angles are congruent to one another because they are alternate interior angles. And before we head into some of the questions, just make sure you have your calculator to follow along and that you're also in degree mode on your calculator. All right, so some questions we're going to look at today have diagrams. I can glance at 1 and 2. Some of them have diagrams that are not labeled. Okay, so notice the difference between 1 and 2 and 3 and 4. And then we have some that have no diagram at all, and we have to draw everything ourselves. So we're going to look at a good variety within this video. All right, let's start with 1. From point P on the ground, the distance to an airplane is 3,000 meters. When the altitude of the plane is 1,000 meters, what is the angle of elevation of the airplane to the nearest degree? One thing I want to point out is altitude is a key word that you will see in the word problems. That means height. So notice the height of the triangle is labeled with 1,000. All right, we're also looking for the angle of elevation. I'm going to put theta in there. You could use x if you would like. And now I'm going to use that to label the sides of my triangle. So here's the opposite side, the hypotenuse, and the adjacent. And now I'm going to treat this like a regular SOH CAH TOA right triangle trig problem. I don't need to worry about the airplane necessarily. I just need to think about, okay, what trig equation am I going to use here? And in this case, it's going to be sine because I'm using the opposite and hypotenuse sides. So sine of theta is equal to 1,000 over 3,000. We are going to do the inverse operation in order to find the measure of theta. So inverse sine 1,000 divided by 3,000. You can follow my calculator work on the right hand of my screen here. And we're looking for the angle of elevation to the nearest degree, and we get 19 degrees here. Okay, number 2. A hot air balloon is secured to the ground by a stake and an 82-foot rope. From the balloon, the angle of depression is 52 degrees. Find the height of the balloon to the nearest foot. All right, in order to use SOH CAH TOA, we need to use one of the acute angles that's in the triangle. That 52 degrees, that angle of depression, is not in the triangle, but we want to use it somehow to find an angle on the triangle. That's why we mentioned before in this video that the angle of depression and the angle of elevation are congruent to one another, so I'm going to use that to fill in the angle of elevation at the bottom. Alternatively, if you wanted, you could also find the complement of 52 degrees and use that acute angle at the top. However, I'm going to take the angle of elevation approach. We're looking to find the height of the balloon, so I'm going to put an X over on this side that represents the height. All right, so here's my opposite side, adjacent, hypotenuse, and this turns out to be another sine example. So sine of 52 is equal to x over 82. While it's another sine question, take note that we're now looking for a side length rather than an angle. So we are going to cross multiply here. So x is 82 times the sine of 52. Hit enter. And we're looking for the height of the balloon to the nearest foot, and we get 65 feet as our answer. Number 3. Okay, now we start to have diagrams kind of drawn for us. However, there's no numbers at all on the diagram. A flagpole 15 feet tall casts a shadow 9 feet long. Let's think about that for a second. If the flagpole is 15 feet tall, the height of it is 15. For a shadow, think about where do you see your shadow? You see it on the ground, so I know that this is going to be 9 down here. And find to the nearest degree the angle of elevation we talked about before, where that's located from the horizon, the horizontal going upward. All right, so now we're going to label our triangle, opposite, adjacent, hypotenuse, and we're going to pick our trig function. This is a tangent problem. So tangent of theta is 15 over 9. Since we are looking for an angle, we are going to use our inverse operation. So second tangent, 15 over 9. And we are looking to the nearest degree. So this is going to give us theta is 59 degrees as our answer. Number 4, Maggie's flying a kite and she lets out 200 feet of string, which makes an angle of 27 degrees when she secures it to the ground. Okay, think about a kite. When you are flying a kite, the string is kind of going diagonally. So I know the hypotenuse of this triangle is the 200. It's making an angle of 27 degrees with the ground, so I'm going to fill in 27 degrees by that angle of elevation. And it says, assuming the string is straight, how high is the kite? And we're looking for height, so I'm going to put an X over on this vertical piece. All right, label opposite, adjacent, hypotenuse, and you'll see that this is a sine question. The sine of 27 is equal to X over 200. X is equal to 200 sine 27, and we're going to put that in our calculator. To the nearest tenth, I have 90.8 feet as my answer for 4. Number 5, a ladder leaning against a wall makes an angle of 68 degrees with the ground. We see the ladder here, so let's put the 68 with the ground. If the foot of the ladder is 4 feet from the wall, the foot of the ladder, it means the bottom of the ladder. Think about your feet. They're at the bottom of your body. The foot of the ladder is the bottom of the ladder, and it's 4 feet from the wall. So I know 4 feet is going to be this bottom piece here. Let's say you were thinking for a second that the 4 should go on the vertical piece. If you keep reading this problem, you'll see that that's not the case because we want to know how high on the wall is the ladder. So our variable has to go over here. So you could always read the entire problem to try and give you some hints and use process of elimination. All right, opposite, hypotenuse, adjacent, and you'll see this is a tangent question. Tangent of 68 is equal to X over 4. We are going to cross multiply here since we're looking for a side. So X is 4, tangent 68. And to the nearest tenth of a foot, I get 9.9 feet. All right, for the last couple of problems, we are going to have no picture given to us, but it's actually pretty easy to start these because all of these problems are dealing with right triangle trigonometry. So you know that you have to have a right triangle. So before I draw anything or do anything or read the question, I'm going to draw a right triangle. Now I'm going to see if I can place the numbers. An airplane ascends. That means it's going up at an angle of 16 degrees with the ground. Okay, so imagine the airplane going upward this way. Find the horizontal distance. Horizontal means the piece that has zero slope. It's going from left to right. And we want to figure that out when it has traveled an altitude of 100 meters. Altitude means height. All right, well, we have everything labeled now. So opposite, adjacent, hypotenuse. This is a tangent question. Tangent of 16 equals 100 over x. When we cross multiply here, you'll see that the variable is not by itself. So we're going to have to do an extra step of dividing. So 100 divided by tangent of 16. And to the nearest meter, we have 349 meters. Okay, 2 more here. Number 7. Again, before I read anything, I'm going to just start by drawing a right triangle. Do not worry about it being drawn to scale. A wire attached to the top of a pole. Okay, so this is basically our pole here. Pole is vertical, and this is our wire. Is secured to the ground 15 feet from the foot of the pole. Okay, remember I said the foot of the ladder, the foot of the pole is the bottom. And here's where it's attached to the ground. So this is our 15 feet. And it makes an angle of 53 degrees with the ground. Find the length of the wire to the nearest foot. Well, we've already established that the wire is the hypotenuse. So I'm going to put a variable there. All right, label your sides, and you'll see this is a cosine problem. So cosine of 53 is equal to 15 over x. Cross multiply. And we are going to have to divide here since we have a variable in the denominator. So 15 divided by cosine of 53, and we're looking to the nearest tenth, so we get that x is equal to 24.9 feet. All right, let's look at one last problem in this video. Number 8, I'm going to draw my right triangle. And it says a 10-foot ladder rests against a building. Well, we saw a ladder question already. The ladder is always diagonal, the hypotenuse, so I know that this is 10. The base of the ladder is 7 feet from the building. That tells me this is 7 down here. And we're looking for our angle. So let's label our sides. And we have cosine of theta equals 7 over 10. We have to do inverse operations here since we are looking for an angle. No cross multiplying on this one. Inverse cosine in our calculator. And to the nearest tenth, I get that theta is equal to 45.6 degrees. So to summarize this lesson, when you are doing a trig word problem, once you have the labels put on your right triangle, you're going to just continue solving like normal, whether it be a side or an angle.